welcome back. In the previous lecture, we had introduced the nature of multipole radiation and the selection rules in gamma decay. We will apply these rules to some of the transitions. So here we see uh, a gamma ray transition from a metastable, M refers to metastable, cobalt nucleus to this nucleus and later to nickel. So what do you need to know the what kind of multipole radiations are allowed? For this, we need to have information about the nucleus spin states. So a lot of information provided here. So these are associated with half-life. Some are associated with energies and so on. But what is important for knowing what kind of multipole radiation come out, what is needed is the information on spin states. So initial spin state is 2 plus, that means it's of positive parity. The final spin state is 5 plus. Here also all the parity are, the parity quantum number is +1. So in the previous lecture, we had mentioned that when there is no change in parity, going from here to here, or going from here to here, or from here to here, there is no change in parity. So only even electric multipolar radiation are allowed, and odd magnetic multipolar radiation is allowed. Then we will implement another formula. So given this and this, the maximum L allowed is 2 plus 5, 7, and the minimum L allowed is 5 minus 2, that is 3. So L can vary from 3, 4, 5, 6, and 7. And putting this information together with this information, the allowed multipolar radiations are M3, E4, M5, E6, and M7. So you should know how to get this because from the material presented in the previous lecture. Then cobalt beta decays and moves to nickel. Here, the initial spin state is 4 plus. The final spin state is 2 plus. So allowed L is 2 plus 4, 6, and minimal L is 4 minus 2, 2. So it can be 2, 3, 4, 5, 6. And with this information, what is allowed is E2, M3, E4, and so on. So again, implementing the formula, I plus IF, so in this case is 2, I minus IF is also 2. So the allowed transition is, the multiple radiation is E2. So even though these are allowed, what is observed is only the lowest, the one with just the octopole is allowed. Okay, so it becomes increasingly harder to get all these things. So what is experimental? I mean, this provides all possible allowed multipole radiation, but only the lowest possible multipole is observed in experiment. Likewise, here there are many possibilities, but what is observed is the lowest multipole. Same, here there's only one multipole that is allowed. That's what is observed in experiments. So gamma ray spectrum has a lot of information, especially it has information on excited state energies, right? So always you see some information on energies that is present. All these information is obtained from some kind of gamma spectroscopy. So it also, from gamma spectroscopy, from gamma spectrum, you can get idea of nuclear spin based on what kind of spectrum is observed, and also has information on nuclear parity. So in the next brief lecture, we will address a few minor topics that will be taken up in the next lecture. Thank you.